Welcome to the Deep Dive.
Hello.
This is where we take, a huge stack of information, research, articles, technical guides, and we really just try to boil it down for you.
Right, we do the reading to give you a shortcut to being genuinely well-informed on a topic.
And today, we are tackling something. Well, it's massive. It's the entire world of construction site safety training.
It really is. I mean, if you've ever wondered what it actually takes to keep a modern construction site safe and, compliant.
It goes so far beyond just wearing a hard hat.
Oh, way beyond.
So our mission today is to really get a handle on the sheer breadth of this. We're talking specialized procedures, permit-to-work systems even things like managing lightning risks.
Exactly. The sources make it clear that safety isn't a simple checklist. It's more like a dynamic matrix.
A matrix, I like that.
Yeah, because it has to cover specialized equipment, but also general human health risks like heat stress and then these really deep, rigorous compliance rules.
And it all has to work together perfectly, all the time.
All the time.
Okay, so let's unpack this. Where do we start? I think we should start with the most immediate, the most visceral threats.
So the big risks.
The big risks, yeah. Where the environment itself, gravity, electricity, can be the most unforgiving.
Well, if you're going to rank them, fall protection is almost always at the very top of that list.
Statistically, right?
Yeah, statistically, it's the leading cause of fatalities. It's why all the training materials just hammer this point home again and again.
And the training gets into these three essential lines of defense, right? It goes from passive to active.
That's right. You start with guardrails and safety nets, the passive systems.
And then you get to the active stuff, the personal fall arrest systems.
Your harness, your lanyard, the anchor point.
Yeah.
And this is where people, I think, are often surprised by the technicality of it.
It's not just about strapping it on.
Not at all. You literally have to do the math. You have to calculate the free fall distance, the deceleration distance.
And the clearance distance.
Exactly, the clearance distance. You have to know, based on where you anchor, if you're actually going to hit the ground before that system even has a chance to catch you.
That's a huge insight. So it's not about having the gear. It's about being like a mini engineer for a second.
For every single setup, whether you're on a roof, on scaffolding, or just up on a ladder.
That same level of rigor, that procedural thinking, that carries over when you're managing energy, right?
Yeah.
Specifically, electrical safety.
Absolutely. I mean, you're surrounded by hazards. Cords on the ground, exposed wires, overhead lines.
So what's the core defense there?
It's a procedure called lockout-takeout, or LOTO.
LOTO. Okay, so this is the system for controlling hazardous energy.
Right. When a machine is down for maintenance, you're not just, hoping someone remembers not to flip the breaker.
You're following a documented protocol.
You're physically locking that power source in the off position and attaching a physical tag that says who locked it out and why.
So it shifts the accountability.
Completely. It moves it from just being aware to a documented, verifiable physical control. That power source cannot be turned back on until you, the person who locked it, physically remove your lock and your tag.
Which forces everyone to be on the same page, management and the worker.
Exactly. And you see that same need for specialized awareness with heavy machinery.
So we're talking forklifts, cranes, loaders.
Right. And the training gets really practical here. It's not just, here's how to drive it.
What else is there?
It puts a huge emphasis on pre-shift inspections and, maybe surprisingly, a really detailed awareness of blind spots.
Ah, okay. That makes sense.
So many accidents happen when a machine is just starting up or reversing because the operator literally cannot see the person on the ground.
So knowing the machine's blind spot is just as important as knowing how to steer it.
Precisely. And we see that same kind of technical complexity when we're talking about excavation and trenching.
Which is way more than just digging a hole.
Way more. The training is incredibly specific. You either have to create safe angled slopes, that's called sloping or benching, or you install these heavy-duty shoring systems to stop the walls from collapsing.
But the sources say you have to do something even before that.
Yes. You have to perform a soil analysis.
Why?
Because the stability of those trench walls depends entirely on what kind of soil it is. Is it stable rock? Is it stiff clay? Or is it, loose granular sand?
So you have to classify the soil.
Right. Type A, B, or C. That classification tells you how steep your slope can safely be. It's basically applied geology on the fly.
And then, of course, once you're in that trench, you have to check the air.
You have to check for dangerous atmospheric hazards.
That need to check the air quality is actually a perfect transition because we've been talking about physical threats, things you can see.
Right.
But what happens when the danger is invisible, when it's in the air itself?
Well, that takes us right into the hidden hazards and these highly specialized spaces.
Yeah.
Once you move beyond a simple fall or an exposed wire, the procedures get even more intense. Let's start with confined spaces protocol.
So confined spaces. We're talking about tanks, manholes, storage pits.
Exactly. And they are just these huge procedural challenges because the risks are so immediate and so lethal.
The list of requirements must be pretty long.
It's extensive. You need a formal permit to even think about going in. You need detailed atmospheric testing.
There's that air check again.
There's the air check again. A detailed rescue plan has to be in place before entry, and you need entry and exit logs.
And that atmospheric testing is really the life or death checkpoint, isn't it?
It is. You're testing for 3 things: oxygen deficiency, combustible gases, and toxic fumes. A moment of bad air can cause immediate incapacitation or an explosion.
So you need this whole documented system with multiple people just to send one person into a tank.
Including a dedicated attendant, someone standing right outside who is in constant communication and is ready to trigger that rescue plan. It's mission-critical stuff.
Okay, so that's spaces. Let's move from spaces to substances. The threat of the unseen. Chemicals.
Right. And the main administrative tool for that on any site is called hazard communication, or HAZCOM.
HAZCOM. This is the entire system for chemical safety.
And it's all about documentation. Every chemical has to have a clear label, but the most important part is that you have access to the safety data sheets, the SDS.
If you don't have the SDS, you're flying blind.
Totally blind. The SDS is your practical guide. It tells you what's in the chemical, what PPE you need to handle it, and crucially, the specific emergency steps.
What to do if it's spilled or inhaled.
Or catches fire. A worker doesn't run to Google, they run to the binder to see if they need a simple respirator or, a full face shield and specialized ventilation.
And this training also has to cover some really specific material hazards. Things that are kind of historical, but also very current.
You're talking about things like asbestos and lead awareness.
Exactly. Training isn't just don't touch it. It's about safe identification and handling, because you still find this stuff all the time in demolition and renovation.
But the sources are clear that a contemporary problem, dust control, is just as critical.
Specifically, silica dust.
Crystalline silica dust, yeah. From cutting concrete or stone. This stuff requires rigorous respiratory protection because it can cause silicosis, which is a horrible lung disease.
So safety training is moving beyond just protecting you from an immediate accident and into long-term health protection.
That's a critical shift. Which, speaking of layered risks, brings us to welding and hot work.
Okay, so welding. You've got extreme heat, intense light.
Noxious chemical fumes, and a huge fire risk, all at the same time.
So the training has to demand specific ventilation to protect the welder from the fumes.
And really strict controls for fire hazards, especially if you're working near anything combustible.
It really feels like every single high-risk job needs its own mini-system.
That's a perfect way to put it.
A lockout for energy, an SDS for chemicals, a separate permit for hot work.
That is the nature of comprehensive safety.
So we've hit the big physical dangers, the procedural maze, the chemical hazards. Let's try to pull this all together now and talk about the human element and, I guess, the administrative glue that holds the whole program together.
Okay. A good place to start is what you wear. PPE.
Personal protective equipment. The last line of defense, as you said.
It is.
And the list is pretty comprehensive. Hard hats, of course, safety glasses, gloves, steel-toed boots.
And then, as we've noted, the specialized gear, your respirators, your harnesses. If there's a foreseeable risk to a part of your body, there's a piece of PPE mandated for it.
But safety training is also getting much more concerned with that long-term protection we mentioned.
Which is why the training on ergonomics and manual handling is so important now.
Right. This is all preventative. It's about stopping those long-term back injuries, musculoskeletal disorders, MSD.
Yeah, through proper lifting techniques, keeping the load in the power zone, close to your body, using mechanical help when you can. It's about making sure your body lasts as long as your career.
And connected to that are a couple of other health items.
Noise and hearing conservation is a big one.
Using earplugs, earmuffs properly, and then the inclusion of wellness topics right alongside first aid.
Yeah, I found the scope of that fascinating.
Me too. It covers the standard first aid, stuff reporting injuries, how to use an AED, dealing with heat or cold stress,
But then it explicitly adds stress management and substance abuse awareness.
Which is a total acknowledgement of the human factor.
100%. A worker who is distracted by external stress or whose judgment is impaired is an unsafe worker. It doesn't matter how good their PPE is or how thick the procedure manual is.
But for any of this to work, the training, the PPE, the site itself just has to be organized. Which brings us to the most basic thing of all,
Housekeeping.
housekeeping.
And you have to underscore this. Safety starts with basic order, preventing slips, trips, keeping walkways clear.
It sounds so simple. Don't leave a piece of scrap wood with a nail sticking out of it on the floor.
It sounds simple, but a messy site is the ultimate leading indicator. If basic housekeeping is being ignored, you can bet that the complex procedures, like LO-TOW, are probably being ignored too.
So housekeeping isn't just about looking tidy. It's a sign of procedural discipline.
It's the foundation of it. And that whole effort is held together by this overarching procedural framework, the administrative map.
So we're talking about the mandatory stuff, emergency plans.
Robust emergency plans, yep.
Mhm.
Formal risk assessments before you start any new phase of a project.
And those permit-to-work systems we mentioned. The ones that act like a control tower for all the high-risk jobs.
Exactly. Confined space entry, complex rigging, hot work, all of that.
And there's one last piece that the sources mentioned, something people outside the industry might not even think about.
Site security and public protection.
Right. Managing who comes on and off the site, but also actively protecting the public pedestrians, neighbors, traffic, from the work itself.
From falling debris, construction vehicles, all of it.
Wow. It's clear that comprehensive safety is it's a monumental management challenge. So, after all this, what's the core insight? What should we walk away with?
I think the core insight is that construction safety is a complex matrix and nothing in it works in isolation.
It's not a list of steps, it's all happening at once.
It's simultaneous. Environmental awareness, like knowing a thunderstorm is coming, has to merge with procedural rigor, like your ODO permits.
Which has to intersect with chemical knowledge, like your HAZCOM sheets.
All perfectly,
Yeah.
because failing on any one of those points, whether it's bad soil analysis in a trench or the wrong respirator for silica dust, can lead to catastrophe. It requires constant, deeply integrated management.
That makes perfect sense. Okay, so given everything we've talked about, that training has to cover everything from heat stress to asbestos awareness to complex rigging, here is a final provocative thought for you to consider. How does that final requirement we mentioned, the need for robust site security and actively protecting the public, how does that fundamentally change the definition of a safe work environment? Especially when you combine it with all these high-risk physical, chemical, and atmospheric elements.
Does the definition of safety extend beyond the hard hat line?
Exactly.
Does it? That's a great question to end on. It really makes you think about the site's place in the wider community. Thank you for joining us for this deep dive.
We'll catch you next time.